So the coding challenge called reverse single linked list. Now in the interview we are given a head, right? Head of a linked list, and what we need to do is just reverse all the elements, all the nodes, and return new head, which in this case would be C, which will be a head of a reverse linked list. So in our case, this would mean that when we do a reversal, right, and return the head, instead of printing A, B, and C, we would print C, B, and A. Cool. You can take a moment and try to code out the solution yourself. If not, let's do it together. When it comes to linked list problems, it's all about pointers, right? So we have few variables that point to nodes, and we need to be careful what we point to and what we change, so we don't lose our pointers to the next node, etc. Right? So in this case, if we want to solve this, we would have few pointers. Let's say that we have none, something that points to none. So instead A points to B, we would just change this. But before we do this, we of course lose the ability to go to B. We need to temporarily save this variable and move forward, right, with our pointers. So now it's B. B points to A, right, and C points to B. And once we're once our current node is none, we just terminate the while loop, like so. Cool. So let's see how this would look like in code. So if we have, let's say, head, we have node which has value A, the next node would be B, and then C, like so, right? If we print head, we should see all the nodes. So let's first implement class node. It inherits from object, and we need the constructor function first. So init. So we have self, we have value, which is always present, and next, which can be none. Self.value is value. Next is next. The next thing we need to do in order to the Spring function would work, so we need to have str. So let's have results, which will be array, and current node is self, while current is present, it's not none. We can append value. We need to move current to the current.next, and we return joint values from the results. So if we print this, if you run the code, we see that we get back, we constructed a linked list from A, B, and C, and we get back this nice representation of linked list. Cool, so this works. Next thing we want to do is just reverse head, and we will get new head here, and we can just print the new head. Cool. Next thing we need to do is just implement this reverse function. So we get node. Let's have current points to node, previous points to none, while current is not none. What do we need to do? We need to save current.next before we move the pointer. So current.next points now to previous. Previous becomes current, and current becomes temp, like so. Once we're done, we can return. We cannot return current because this is none, but we can return previous pointer, which is the new head. If we clear the output and run the code, yeah, okay, that's the problem. We need to print the new head. Let's clear the output and run the code, and yeah, we get what we expected. So the first print is this guy here. We get ABC. We reverse the linked list, and next we get the reverse linked list, which is C, B, and A. Cool. Do we need to talk anything? Okay, so let's talk about time complexity for this one. So it's basically of n, and it's the number of elements inside the linked list. This is the runtime. And for space, we're actually reusing stuff, so it's constant. Yep. So that's about it.